Great privilege and pleasure to have a chance to talk to Antony Hewish, who I am under the fond delusion was in the room where I now work just before I was there, which we will check afterwards. But Antony, tell me first where and when you were born.
I was born in Foy, in Cornwall, in 1924. My father was a banker there. He was manager of Barclays Bank in Foy, in Cornwall. Lovely little port. And we left, unfortunately, before I was fully one, and went to the north coast, to Newquay, which is surfer's paradise nowadays, and a place I really don't visit very much anymore. But it was Newquay where I was actually brought up, on the North Cornish coast. I mean, pre-war days, pre-World War II, it was a very nice place. I mean, it was a holiday town, but it hadn't been spoiled by too many organisations and surfers and things. The coastline is absolutely marvellous, and I can't really think of a better place to be brought up. I went away to school in Taunton, but getting back for school holidays and long summers playing around with crabbing and all that sort of thing was marvellous.
When you mention crabbing and things, I mean, a lot of the scientists I've talked to, particularly the biologists, have got their first interest in science from wandering around and watching birds or picking up shells or something. Do you think wandering along the beaches of Cornwall had any influence on your later career?
I think it may have guided us a little, but I was more interested in physical things. I mean, the sea as a background to escape to and just enjoy myself. But at home, we had rather tolerant parents, and we got away with doing all sorts of minor experiments. I mean, we used to plug into or rather we used to pull the mains leads out of the wall and get connected up and do that sort of thing. My brother, I'm the youngest of three brothers, and it was the middle brother, John. He was 3 years older than I was, and we were both rather technically minded. He was particularly interested in building model aircraft and things of that sort. And jointly we did all sorts of crazy things. I mean, the sort of thing boys do, making explosives. and I particularly tried electrolysis using the mains, which didn't help because we lived above the bank. He was manager of Barclays Bank in Newquay, and we lived in the bank house, and so we were on the first floor. And whenever we did anything crazy, it would plunge the bank into darkness beneath. And so we weren't popular on those days. But that was the sort of thing. I mean, what you'd say mucking about in a scientific way is where I got my interest. I love making things and so on, and just how things worked in general. That's how I got into it. But the sea in the background, I mean, was the escape, and just either in it or on it, rowing around, trawling, I mean, spinning for a mackerel and so on. Absolutely marvellous place to be then.
Lovely. Well, you've mentioned your father. Was there any way in which, I mean, there's no obvious link between astronomy and bank management, but was he an intellectual of any kind at all?
Not really. No, I think not. I mean, he was a Devon boy. His parents were drapers in Barnstaple in Devon, and he had a love of the country. Being North Devon, you could hardly not. And he did his early banking in Bodmin in Cornwall, and was a golfer. Newquay has a lovely golf course, and he did much of his bank manager's business on the golf course, I think, as they do. But no, he wasn't in the least bit scientific or technical. He never knew how things worked and so on. So we were just born with this, I suppose, just this natural curiosity. I mean, I was always just wanting to know how things worked, and was inclined to take them to pieces until I knew how they worked, and that's how it was. And we had tolerant parents who let us do these crazy things. I mean, making explosives, which we used to take out on the cliffs after dark and let off, you know, things like that. In those days, you could buy everything you needed for a huge.
Be arrested for that nowadays.
But now you couldn't do it, but you go into Boots and buy the ingredients of gunpowder, you know, and that afternoon you could be making explosives. And So that's how we lived.
What about your mother? What sort of character was she?
Well, she was a Cornish girl, but surprisingly didn't have much liking of the sea. She was very much a farmer's daughter, and she was brought up on a farm, and one of three daughters, and she had a love of the country, but not a great deal else, if you know what I mean. She wasn't an academic in any way. One of her sisters was, and or at least she wrote and that sort of thing. She never went to university. But no, my mother was just a nice country girl, I think, and a wonderful person to bring us up. Very tolerant, but not guiding in the way of scientific or what we did. Maybe a guiding hand about doing dangerous things like climbing cliffs, but no.
Well, you mentioned going to school. Where did you first go to school?
Well, I had my early schooling, of course, in Newquay, and was at the Newquay Secondary School for a bit, but then we got sent to King's College, Taunton. I went away to King's College, Taunton, which is a smallish public school, and I must have gone away then when I was about 12, I think. I went into prep school and all the way through, and I was there for seven years. So that was my main pre-university education.
Were there any teachers at either the primary school or at your at King's School who influenced you much, or?
Not greatly, not greatly. My physics master, Padfield, was a Keys man. He was why I went to Keys eventually when I came up to Cambridge, and he wasn't a great physicist. I mean, he was looking for jobs in the time of the Depression in the 1930s, and he was better at hockey, I think, than he was at physics, quite honestly. He was a hockey blue, and I think that's what effectively got him his job at King's College, Taunton. And but he was all right, and he encouraged and so on. But I can't say I really got great inspiration from my schoolmasters. I think it was self-generated, really. My interest. I mean, schools were much more tolerant then. You could just wander into the chemistry lab and play around with things. And once again, one made things like nitrogen triiodide. I don't know if you know that, but it ignites at a glance almost when you've made it. You just mix iodine with concentrated nitric acid, fuming nitric acid as they call it, and it dries out into a black powder, which if you have it on a paper and shake the paper, it ignites. And
this is going on to YouTube, so I hope
so perhaps I shouldn't say these days. Well, you can't buy these things now. You need licenses to do all this. But no, I think it came really internally from inside me. Nothing sort of pointed me in any particular direction.
There wasn't any particular book or anything?
No, not really. No, it just came out of, I think I must have been born with it, actually.
Were your brothers at the same school?
Same school, no. My middle brother, John, was, and we were the close brothers. My brother, Paul, went into banking, but he was 6 years older than I was, you see, and that's, when you're young, that's quite a gulf. And, I mean, we got on well together, but he was doing quite different things.
Did you enjoy being at that school? Some people have.
Moderately. I didn't hate it, but I mean, I wasn't wildly athletic or sporty. I mean, one had to play rugger most afternoons of the week, which I tolerated, but I didn't excel at that particularly. The pinnacle of my sporting career was getting school colours for cricket, you know. I'm sorry, not school colours, house colours. I mean, we had 4 houses, as public schools do, and I played for the house and made a few runs once and got my colours. But I didn't regard myself as any sort of sportsman. I did it reluctantly, I suppose you might say. I was happier playing around with things in the lab. And in those days, most of the playing was actually in the chemistry lab rather than the physics lab.
Was there any other hobby you had? I mean, were you interested in music? Have you been interested in music?
I am now, but that's through my marriage. That came later in life. I had the option to play the piano at school, but it was what we called a sissy thing to do in those days. I mean, young boys at boarding school didn't do that, and, so I didn't, much to my regret, actually.
You didn't sing, or?
No, not then. We had school chapel twice a day, and that was enough singing for me, actually. But I didn't have a natural aptitude for music. I mean, I played in the bugle band, you know, for the for what we call the OTC in those days, the Officers Training Corps, and that was a way of escaping too much square bashing, because if you were in the band, you led a slightly different life. And, but that was the pinnacle of my musical career at school, was playing bugle in the OTC band. But you can't call that really being very musical, I think.
But you mentioned later, through your marriage, you got interested in music.
Yes, well, my wife plays the piano. She's a teacher. Well, she was a teacher, and she was quite good on the piano, and she got me going to concerts. I mean, I met her when I got back to Cambridge after the war, and it was just when I was about to start research that I met her, and we've been together ever since. And she's, as it were, led me gently into the higher reaches of music, and I simply love chamber now and opera and that sort of thing. Not so much large orchestral concerts, but chamber music where you can actually see what's going on and see people interacting with each other. And that's a great release, actually, and a big part of our lives now.
Do you think it's fed in any way into your work, music?
I doubt it.
You
really.
doubt it?
No, I don't.
The music of the spheres?
No, I mean, I'm rather down to earth. I mean, I plug things in and try and get some information. I mean, I had no great aspirations to solve the riddle of the universe or anything like that. It's just that when I came back after the war, I had some electronic technology which I understood, and discovered that it was going on in Cambridge, and went and began research there because it was the obvious option for me. But I hadn't planned to be an academic, I must say. No one predicted I was going to get a first in my part 2 finally.
Well, we'll come back to that.
Come to that later on, but no
music. Right. Well, let's move on then from school. You went to Keys?
Yes, I went to Keys because my hockey playing physics teacher, Padfield, said it was a college of a reasonable size, not too big, not too small, and he was very happy there. And of course there was such a desperate shortage for trained scientists during the war that you could get to Cambridge very easily, and they would fund you. And
this was just before the war, was it?
No, this was in 1943. Actually, I had a well, I came up to the university in 1942.
Yes.
The war was on, and they were desperately keen to get more scientists, particularly into radio and radar. And I came up as what was called a radio bursar. They funded you, and in those days there was a 2-year course, an accelerated course, to part 2 of the natural sciences tripos. But because of my background in rowing and so on at Newquay, I spent, I think, too much time on the river in my first year. I'm desperately keen to row in an H, you know, and get that lovely feeling when everything is synchronized and so on. And I spent afternoons practicing on the river when I should have been in the physics lab. And I didn't do very well at the end of my first year. And the authorities said, well, I think you better go off and do something useful for the war effort. So I was directed to the Royal Aircraft Establishment, Farnborough, after just 1 year. And I spent 3 years there until the war ended, for which I was immensely grateful, actually, because the experience, my wartime experience, I began to understand what physics and some aspects of maths were really about in a way that I hadn't realized when I was an undergraduate. I mean, I recommend people to go to university rather late in life if they can. At least it suited me. I mean, I came up to Keys when I was 18, and I wasn't really very well versed in how the world worked. I mean, boarding schools kept you enclosed. I mean, you weren't allowed even into into Taunton. We were just in a monastic atmosphere, really, and that's not too good for one's general education, I think. So I was really rather immature, I suppose you might say, when I came up to Cambridge. And I should have worked harder, and I didn't, and they sent me off to Farnborough.
What was the nature of your work in Farnborough?
Initially radio communications, radio receivers and things, but I hadn't been there more than a few months before I was directed to TRE, which was the home of radar, the boffins.
What is TRE?
TE, it stands for Telecommunications Research Establishment, but the name means nothing. It was where radar was essentially invented during the war. All the airborne radar applications were going on there. And I had the job there, not of developing particular equipment, but on training the aircrews actually how to use it. My job was called PDS, Post Design Services. Having worked on the development of a particular gadget and seen it through production stage, then you went out to the squadron where it was being fitted. This in my case, this was Bomber Command, and I was involved with the device for jamming German airborne radar. And what the device did was to radiate noise at high power from the tail end of actually a B-17, the American Flying Fortress. And these aircraft flew in the bomber stream, and the idea was to blanket the German interception radar on their night fighters. I mean, I don't really know how effective it was, but my job was to teach the ground crews how to service it, and the air crews how to twiddle the knobs, you know, and very interesting. But not actually a design job from my point of view. I mean, I had to know exactly how it worked and everything, but I didn't design it. I got to know it after the initial design prototype had been made. And that's where I first met Martin Ryle. He was head of that radio countermeasures group, as it was called. And
how much older than you was he?
Beg what?
How much older than you was he?
He was about 2-3 years. He was an Oxford man, and I think he must have been about 3 years older than I was.
And you worked very closely with him for many years.
Yes, he was in charge of the of developing the gear at TRE Malvern, and so I got to know him pretty well to begin with. And I had no idea actually he'd returned to Cambridge when I came around to see what research I might be involved with, but I discovered he was here, and it was an obvious thing to do. I mean, I met when you couldn't be in his company for long before realising how immensely bright he was. He always thought up solutions before you did, and was a wonderful man actually in many ways.
Yes, I was going to ask about his character and mentality.
Yes, I mean, a very reserved sort of man, and could go off the handle rather rapidly, and but on the other hand, immensely kind and thoughtful, and I found him a wonderful person to work with.
You spend a lot of time talking together.
Quite a lot, quite a lot.
Crick and Watson and so on spent their
time
chatting.
Yes. But I mean, he was just so down to earth and natural. You couldn't help liking him.
So at the end of the war, you came back to finish off your degree?
I came back to finish off my degrees, and I was here for 2 years then. And
this is in 45. You came back.
I came back. Yes, I came back in 46 actually. 46. October 46, and took life more seriously. Naturally, it was a wonderful time to be in Cambridge because all the ex-service people were coming back, and so you were in the company of people you'd been with. I mean, not necessarily personally, but the types you'd met during the war. The post-war years were sort of legendary. If you talk to tutors who are still alive now, they wanted to learn. They worked hard. They didn't play around. I mean, partying didn't really exist in those days, and they were just wonderful people to talk to. I mean, you talk to people who had been in fighter pilots and that kind of thing. Cambridge was a very interesting place, but I didn't naturally find physics easy. I mean, I'm not. Mathematics doesn't just flow into my head. I have to work rather hard to find out what it's all about. But after the war, I realised what the mathematics was doing, things like Fourier analysis. I saw the power and point of it, because this had been used in my wartime experience, and so I came back much wiser, and I spent less time on the river. In fact, I spent no time on the river when I came back, and I worked quite hard and ultimately got a first.
Mm.
But that was again partly due to my wartime contacts, because the man who was running radio physics at the Cavendish lab, Jack Ratcliffe, who's with us no more, I'm afraid, he was a research student with Edward Appleton, who discovered the ionosphere, and there was a strong tradition of radio physics here in the Cavendish, and Ryle had gone to work with Ratcliffe after the war, and as I said, when I had the chance, finally, I got my first, and Ratcliffe had been a very influential teacher to me. His courses on electromagnetism were legendary, and he was one of the big influences. I mean, I really got to grips with electromagnetism on the practical level, and when I found I could do research in that area, in Ratcliffe's group, Ryle was then not group leader, this was an obvious thing for me to do, so that led naturally through. But I hadn't planned to be an academic, I have to say. I'd got jobs lined up, but my tutors, after I'd been, this was in the summer of 1948, they said, have you got a job yet? Because don't make up your mind too quickly. Keep your options open for a while. This was before the results came out. They knew what the results were, but I didn't. and I got a first, much to my surprise. Although I had worked hard, it wasn't a total surprise finally, because I was getting to grips with things, and but I hadn't planned to be an academic. But when I had the chance to do research, and I discovered there were interesting things to do, for which I was fairly well equipped, and together with that, I'd met my girlfriend in Cambridge, who was teaching, and that was a nice thing to stay on in Cambridge. So everything clicked and came together, and that's how I got into research.
Radcliffe, you said he influenced you. Was he your tutor or your...
No, but he gave
lecturer?
Excellent Part 2 lectures in electromagnetism, and everybody speaks very highly of his teaching abilities. And I met him. He was, in fact, head of the post-design services group at TRE Malvern, and I'd interacted with him during the war, so I already knew him, you see, and so he was a big influence, I think one could say.
Were there any undergraduates at your time? I mean, any people who you've remained friends with or who have influenced you in any way?
What, since then, you mean?
Yes.
When
I mean, do you have any famous compatriots, or whatever the word is?
Famous compatriots. Well, in radio astronomy, I think, well, people like Graham Smith, of course, who's still alive. He was a colleague at TRE. He was a year ahead of me at TRE, and
did he come back to Cambridge?
He came back to Cambridge to do research. He'd done a rapid 2-year course, so he was fully qualified, and he was working with Martin Ryle. He joined Martin Ryle began research in 46. I began in 48, and Graham Smith had joined in 47. So that he'd been doing research for a year when I arrived. But it was a sort of family affair, and it was picking up wartime connections in a sense. And radio astronomy, I mean, no one knew what it was going to. It was a continuation, in a sense, of our wartime work together, because no one knew that it was going to open a new universe to us. We were just playing around with the technology we understood, investigating these strange radio waves from the sun initially, because that was a wartime discovery, radiation from the sun. That's how radio astronomy began in this country.
Who made that discovery?
That was James Hay, who was a wartime radar man.
Is that with an A-Y or
H-E-Y?
E-Y.
He discovered radiation from the sun. He was with operational research with anti-aircraft, and on one day the anti-aircraft radars were swamped. This was in February 1942, just after the pocket battleships had made their dash through the Channel, and it was thought initially to be some sort of new secret weapon of the Germans that's blinding our radar turned out to be coming from the sun. He realized that when he discovered that all the radars that had been blanketed were picking up radiation from a certain direction. It was a dull day, rather like today, and he phoned the Royal Greenwich Observatory to say, was there anything funny going on with the sun at that moment? And they said, well, it just so happens there's an active sunspot right in the middle of the disk. And so that clicked. And that was a secret wartime discovery then. That was 1942.
Mm.
But Ryle thought this would be a good thing to investigate when he got back to do research in Cambridge. Mm. And so that's how it began. But then, of course, radiation became known from other directions too. Mm. And I got in on the ground floor, as it were, just when that was beginning. So I was extremely lucky.
What was the theme or thesis of your thesis, so to speak? What were you particularly studying in the PhD?
Well, this may sound a little odd, but it wasn't astronomy for its own sake. What I had discovered in about my first year of research was that radiation from these few, what we now know as radio galaxies, but we call them radio stars in those days, the radiation fluctuated in time, and it wasn't clear whether this was an intrinsic variation of the sources themselves, or whether it was a propagation effect, whether the radiation was being affected on its traverse through the upper layers of the ionosphere here. And Graham Smith had already made measurements which suggested that it was an ionospheric effect, and I took that up and confirmed that in fact the fluctuations were caused by mainly nocturnal disturbances in the ionosphere. It was my initial research that led to the discovery that this only happened at night, this fluctuation of the sources. And so I thought, well, here's a jolly good way actually of using extraterrestrial radiation to probe the atmosphere at heights which were then unreachable by any other method. And because the astronomical side hadn't really developed, the mystery of what radio galaxies were, I mean, the term radio galaxy didn't come for several years because we thought these were stars in our own galaxies, like the sun. I really got diverted to using radiation, extraterrestrial radiation, to study the upper atmosphere. Jack Ratcliffe, who was an ionospheric scientist essentially, was keen, in fact, that I did this, and he gave me great support. And in my thinking about this, I developed a bit of theory, which pleased him a great deal, and I sort of latched onto this as my own particular research area. It's nice when you're a graduate student, you know, to have something that you can call your own. Mm. Martin Ryle was so bright that he'd thought of all the clever things to do weeks before you could think about it. But here was something which I could develop on my own, you see. And so I got on with that, and that was what my thesis was all about, in fact, using radiation from what we now call radio galaxies or supernovae to just as a source of radiation from outside the atmosphere, and investigating the fluctuations and what they could tell you about the properties of our own ionosphere at heights of 100, 200 miles. And measuring wind speeds, for example, up there. I was the first to measure the speed of an ionospheric wind in the upper atmosphere, upper ionosphere, and that gave me a great thrill. This was research I could manage on my own with not a great deal of technical requirement, actually. It was quite elementary, the radio telescopes technology that I was using, very, very simple. But it was all brand new, and so you couldn't help but make good discoveries and publish papers, and that's just what you need, isn't it, as a starting graduate student.
Where were the radio telescopes? This is before the arrays and so on.
Absolutely, absolutely. We were using wartime surplus equipment up there.
Which, where was it, on the top of the Cavendish or something? Or?
No. We had to get outside Cambridge because of ignition, automobile, you know, car radios and things. I don't mean car radios, I mean car electronics, spark plugs and things, cause a lot of electrical interference.
Mm.
So we were just behind the rugby ground up here, just behind the university library, what we call the old rifle range, still called the old rifle range. And with wartime surplus equipment, that's how Martin Ryle began, and that's what was there on site when I joined up. I built my own primitive radio telescopes to do my own particular jobs, but they were only little bits of wire strung between poles and so on, the sort of thing you could build in a week or two. And once again, this was the sort of thing I'd been doing as a child, you know, playing around, you might say, almost, with stuff that I could handle and make myself. And that was the joy of it in those days. And you could make very nice discoveries with very simple basic apparatus. And
this is the sealing wax and the
sealing
strings.
wax, as you say, string and sealing wax, the true Cavendish tradition. And the giant radio telescopes, of which I was connected, actually came along later.
And it again shows your hands-on interest. I mean, that you liked making things.
Yes, indeed. This was, yes. I mean, it didn't cost a lot of money. This was research that you didn't have to fight for funding. I mean, we had enough funding in the Cavendish to support the sort of work I was doing, so I didn't have to write research proposals. All I had to do was to consult Martin Ryle and Jack Ratcliffe and say, look, this is what I like to do. And they would think a bit and say, yes, that looks worth doing. Go ahead, you know, and in a week or two you'll be starting. Nowadays, of course, it's a very different world, and you have to sit on committees and so on and justify yourself. But in those days it was done more or less with personal contact, and we had the cash. And they were golden days in research, because you could do your own project, get on with it, and within a year have really broken new ground, and I found that immensely satisfying.
When did you first become aware that very close to you a new machine for analysing your results had just been invented? In other words, Wilkes's EDSAC computer.
Oh, right from the beginning, actually, because Martin Ryle, as you know, was famous for his discovery of his invention of aperture synthesis, using radio telescopes, simple telescopes in different positions, and adding up the data. Essentially, you're Fourier analysing the sky, and you need a computer to analyse the data. And the work that was going on, Martin Ryle in the very early 1950s was experimenting on using EDSAC in its earliest form to analyse the data from the simple interferometers he was then using to make simple maps of the sky. And so we were aware of EDSAC right at the very beginning. It was of no help to me to start with, but later on I got very involved with it, because someone had to do the early programming, and that fell to me. But I didn't use actually computers in my own work at all. I just didn't need to. And recording with computers, I mean, we were recording with pens on paper, like electrocardiograms, and I mean, the digital world just hadn't begun, as I'm sure you realise, in the early 50s. It just wasn't there. But we were very conscious of EDSAC, and Martin Ryle had his eyes on it, and we were using that from the very beginning.
Were you aware of Alan Turing at that point?
No. I only read about Alan Turing later. I just didn't know of his work, and I didn't know about Bletchley Park or anything.
That's interesting. So, going on, after you'd finished your PhD,
yes.
What did you then do?
It just developed in a natural way, where I had worked originally on the ionosphere. We then discovered that radiation passing through the sun's atmosphere, radiation passing by the sun, was similarly affected. The phenomena were rather different, but having had the background of working on ionospheric disturbances, I then began to study disturbances in the solar atmosphere, and my work naturally extended out towards the sun, and it developed into studying what we now call the solar wind. The solar wind as measured by spacecraft, this outward expansion of the sun's atmosphere. The sun's atmosphere literally blasts out through interplanetary space at speeds of typically 300 or 400 kilometers per second. That's millions of miles per hour. But this solar wind became known when space research began. And before that era, I was studying, I didn't know it was a wind, but I was just studying the solar atmosphere as it left the sun. And that kept me busy for the early 1950s, actually. The sun's atmosphere can't be seen optically with instruments, except a total eclipse. And total eclipses don't happen very often. To have a means of detecting anything to do with the solar atmosphere any day of the week, as it were, was a useful thing to do. And I tracked the solar atmosphere and studied irregularities in it and how it behaved almost out to the halfway between the sun and the earth. And that kept me busy. For my own personal research, I got quite a lot of papers out of that, research publications. And at the same time, I was helping Martin Ryle in the design of his radio telescopes, the really big ones, which made the first groundbreaking sky surveys in this country. So it led naturally on, and so I had the two things. I was working with Ryle on the design of radio telescopes and doing my own research on the solar atmosphere.
It's not absolutely clear in the accounts I've read as to whose idea it was to space the array, the telescopes far apart.
Oh, well, that was Martin Ryle, totally Martin Ryle. And I mean, Martin Ryle's work went hand in hand with the development of computers. When you're analysing the data from these multiple interferometers, which perhaps I should explain, you can synthesize a radio telescope that you couldn't possibly build. I mean, Bernard Lovell, as we all know, was designing a 250-foot dish, the famous Lovell telescope at Jodrell Bank. But Martin Ryle was a little bit scornful about that, because he said, well, it hasn't got anything like the power that we really need. What you want is a telescope a mile across, not 250 feet. And the way to do that, and this is the reason why he got the Nobel Prize, was to make smaller dishes which are easy to build and not too expensive, and pick up the data sequentially when these are in different positions, and then you can synthesize all that in a computer to reproduce exactly what a mile-wide bowl would actually do. And that was Martin Ryle's bravery, you might say, his courage in realizing that you could actually do this and going ahead and doing it in a big way, using computers as they developed to do the computations. And Martin Ryle's telescopes elaborated as the computers elaborated. But I was involved not so much with the computing side then as with the design of the Martin Ryle's telescopes that he used for the synthesis.
They were on a railway line, I think I've seen them. Eventually, not at this point.
They were on a railway line.
Why
yes.
were they called Mallard, the observatory?
Well, Mallard was kindly provided the money needed to move our work from the old rifle range, which we mentioned, close to Cambridge, to the new site at Lord's Bridge, which is only a few miles away. But Mallard gave us £100,000 to set up essentially the Mallard Observatory. That is to say, establishing the site and the buildings on it, and some funding for the radio telescope, but mostly the funding for the instrumentation came from what was then called the DSIR, the Department of Scientific and Industrial Research. That was government funded, the equipment, but Mallard provided the infrastructure, you might say, for the site.
You often mention, or you do mention in little bits you've read, the word scintillate. or scintillation.
Yes.
Can you explain what's the importance of scintillation is?
Yes, scintillation is a grand title for twinkling. All stars twinkle, and scientifically we call that scintillation. What happens is that I mean, we've all seen stars twinkle, and stars twinkle because the upper atmosphere, even on the clearest nights, has air in it of varying wind speed and varying density, and there are clouds of different temperature and density up there, even on an absolutely clear night. And the radiation coming through is bent in different directions. And so looking through the Earth's atmosphere is a little bit like looking through a crinkly bathroom window. The radiation coming through is refracted in different angles, and what you pick up isn't a pure, undisturbed wavefront. It's waves coming in different directions essentially, and that causes this twinkling phenomenon. And it's the same in radio astronomy, except the physics is somewhat different. But scintillation is just the name given to these fluctuations, and so sources scintillate when you observe them through a disturbed atmosphere.
Thank you.
If that helps.
It does help, yes, indeed, in layman's terms. When did you first, or where were you at this point? I mean, physically, were you in the old Cavendish?
We were in the old.
Was radio astronomy already at the top of Colloid Science Building at this point?
Yes.
So you were already in the room, which I keep alluding to.
Yes.
By this time,
indeed.
In the 50s, you were there.
Yes, indeed. I mean, we were there from the earliest days. I mean, in my case, from 1948 until
1974.
70. Well, in fact, it was a bit earlier than that. 71, 72. I think, can't remember. 72, I think, was when we actually moved to our new site. But we were in those offices.
Wonderful. Oh well, we'll visit them later. Let's begin to move on towards those times. What did you then work on, moving now into the 60s?
When we had discovered that the sun's atmosphere, it was an extension of the work I was talking about earlier on the sun's atmosphere. I did a calculation in 1952, which seemed to me to rule out the possibility that you'd ever see scintillation caused by the solar wind. The reason being very simple, that in those days, when we had a handful of extraterrestrial radio sources, a mixture of supernovae and radio galaxies, they all had a rather large angular size, rather large to an astronomer, that is. The radio galaxies we were looking at then had angular sizes of several minutes of arc minutes. They were about the size of a crater on the moon, to put it in a visual analogue. Now, I had calculated that you would never see twinkling through the solar atmosphere because the sources were much too large to produce a twinkling phenomenon. To go back to what I was talking earlier about stellar scintillation, stars twinkle but planets don't. The moon doesn't twinkle because it has a much too large angular size. Any twinkling is blurred out by the size of the moon or planet. Planets don't twinkle either, not usually. And the reason is, as I've just said, because they subtend too large an angle. And when I looked at the calculations of what the solar wind was doing, I realized that you would never see scintillation because the sources were much too large, the radio galaxies and so on that we then knew. And so I never bothered to look for it. A great mistake, which I may elaborate on later on. But we discovered quite by chance in 1964 that in fact some radio galaxies in the sky did twinkle. It was a mystery, first of all, as to why they should, but a graduate student noted that they twinkled when they were not too far away from the sun. They never twinkled when they were seen at a large angular distance from the sun. And I was talking about, Martin Ryle and I were discussing this. We used to have Saturday morning discussion groups, and he said, could it be that this is a scintillation? And I went back to the books and said, well, it could be if they were incredibly small angular size. Now it turned out that the ones that twinkled best were the ones which by then Jodrell Bank had discovered were in fact rather small. And so we said, well, let's do a proper experiment and see what's going on here. So with a colleague I set up an experiment at our observatory at Lord's Bridge, and we discovered, yes indeed, a lot of the radio galaxies twinkled in fact. And this then opened up the whole field of what I called interplanetary scintillation. Certain radio galaxies, we now call them quasars, but we didn't know in those days what quasars were. The term had scarcely been invented. But if you looked at studying quasars, then they twinkled as observed through the solar wind. And so my work, which I'd been doing in the ionosphere and in the solar atmosphere, suddenly extended, and I realized that I could use this twinkling of certain radio galaxies to measure the speed of the solar wind, which was then enormously interesting because it had just been measured by the first spacecraft. I think it was the Russians who did this. They launched a Lunik, I think they called it, and I'm now talking about the late 60s. They had discovered that the solar wind existed in space. And I said, right, I'm going to measure the solar wind on the ground. And that's when my research took off. And I set up a grid of radio telescopes across England. Well, in fact, I started off with 3, one in Cambridge, one on the East Coast, and one, in fact, the other side of Thetford here. And I successfully measured the solar wind from the ground, and I thought that was terrific fun because here was this scintillation pattern, the pattern of radiation intensity sweeps over the ground, and it was crossing England at a speed, as I said, of about 300 or 400 kilometers per second. But I could just measure the delays as this pattern crossed my different radio telescopes, and I rapidly got graduate students to help, and we measured the solar wind on the ground in competition, as it were, with the earliest spacecraft. And I thought, you know, here am I doing this for a few hundred, well, £20,000, whereas you it's more like 20 million if you 20 million pounds if you do it from space. And I spent a lot of time then, I mean several years, measuring the solar wind from the ground, and that was enormous fun. And we could do better than spacecraft in a certain sense that you could measure the solar wind coming from the polar regions of the sun, which spacecraft didn't manage until the 1990s, actually, quite recently. And we found the solar wind was coming off the solar poles faster than it was blowing off the equator, and that was a nice discovery. But it was just at a straight extension, really, of what I'd been doing before, but applying it to the solar wind, which took my research into the 1960s, and which eventually led on to, in an actual way, to the pulsars.